Next one is identifying different types of data. So we're looking here at qualitative versus quantitative data. Now, as I said before, maths has its own language. So you may never have heard this before, or you might even have heard this in science, or if you're doing psychology, or even if you're doing this through university, this is the type of data you collect. So data can be collected either qualitative or quantitative, and quantitative data can either be discrete or continuous. And this is a rough idea of what it's about. Right, qualitative data. Qualitative data deals with descriptions, how people feel. It basically looks at a relativist type of view of the world, so that the individual is only able to describe how they feel, how they think, what they see, what they smell. So it's very personal to a person's outlook. Data can be observed, but it can't be measured. I mean, how does the fact that the sun is shining right now make me feel? That can't be measured. It's just I can just rate it on my scale, so maybe say 1 to 10. As I said before, it's colours, textures, smells, tastes. Now, a good way to remember is qualitative can be seen as quality. Now, quantitative data is more what you'd expect with maths, as it deals with numbers. Data, it can be measured, such as length, height, area, basically stuff you can just mark out and go, yep, that's quantitative data. I can make it into numbers, that's going to be quantitative. And a good way to remember is the first part of quantitative looks like quantity, i.e. numbers. So, an example is, look at that beautiful oil painting. Okay, I probably should have got a better picture, but it allows you to work through it. So if we're going to look at qualitative data and quantitative data, what data would we collect for that painting? Pause now and just have a few ideas. Welcome back. Okay, so qualitative data is looking at the colours. It's reddy green a colour, it's got a gold frame, it smells old and musty. Look at the brush strokes. Think you're an artist, talk about the brush strokes, about the feelings, about how it affects you. That's qualitative. Quantitative, however, numbers. That is, what is the size of the picture frame? How much does it weigh? What is the surface area? How much does it cost? So, probably not a best way to describe it, but I think of qualitative as pink and fluffy. It's the nice things. Quantitative is pure logic. So, here's a latte. Not that I'm wanting a cup of coffee, but just have a look at that and try and come up with a few examples that would be qualitative and a few examples that would be quantitative. So pause now. Welcome back. So for the qualitative data, I talked about the smell, I talked about the frothy appearance, I talked about how it makes me feel good in the morning. Actually, mine's tea. I always have to have a cup of tea, but I didn't see a good, nice picture of a tea. Now, quantitative, however, would be how hot is it? How much it cost? What was the cup it came in? What was the size of the cup? So, got this for on your whiteboard. So either do a whiteboard in front of you, do paper in front of you, and I just want you to quickly write down whether the data is going to be quantitative or qualitative. So, ages of people. Favorite films ever. Goals scored in a school hockey match. Student's favorite teacher at school. The number of police. The time it takes to get home. And the softness of a pile of towels. Okay, let's go through it. Ages of people. Hard numbers, it's quantitative. Favorite film ever? Well, this is going to depend on the person, so it's qualitative. Goals scored in a hockey match. Pure numbers, quantitative. Student's favorite teacher. Hopefully they'll all have said me, but yeah, you can't account for taste. So that's qualitative. Number of police at a football match. Numbers, quantitative. The time it takes to get to school. Numbers, quantitative. And the softness of a pile of towels. Very nice, but it's qualitative. Now, just to give a little bit more confusion, when we're talking about quantitative, this can be split into discrete data or continuous data. Okay, now to give you an example, discrete data is usually shown in bar charts. I'll explain why later. Whereas continuous data is usually shown in frequency charts, which again we will talk about later. So, discrete can only take certain values, measurements, for example, CDs, number of cows, it's whole numbers. So think of it as discrete it's got no decimal places, it's when you're counting specific things. So for example, shoe sizes, number of children in a class, and the number of sweets in a packet. Now, I know I turned around and said it's whole numbers, and the only thing that is slightly different to this is shoe sizes, because of course you can get 4.5. But it is still only 4, 4.5, or 5 as an example. It's still exact numbers, so therefore it's discrete data. Continuous data, however, it's a continuous measurement. So this is where you have decimal places come in, and the fact that something has to be usually rounded up or put to significant figures because it can go on. And this will be a good example for the information you learned in the last lesson. So for examples for that is, what's the weight of a banana? Well, it depends whether you want to measure it in grams, milligrams, or micrograms. You know, the numbers can continue. What's the time it takes for pupils to get to school? Would you do this in hours, in minutes, in seconds, in milliseconds? The information can go on. And the height of a 13-year-old boy? Well, again, do you measure in meters, in centimeters, in millimeters, etc.? So that includes decimal points. So, let's see if you understand what I'm talking about. If I say, how many cows are there in the field? Is it discrete or continuous data? And we'll find it's discrete because you can only count single cows. You don't really see many half cows jumping around. That would be a little bit weird. How fast can you go in your car? Discrete or continuous? And the answer is continuous because your gauge, of course, can be put into decimals. How much water is there in this bottle? Discrete or continuous? And the answer is continuous because, of course, to measure in grams, milligrams, milliliters, what do you measure? How many CDs do you own? Wow, that's making me old. But for those people who are slightly old and still have CDs, you know what I'm talking about. Discrete or continuous? And it's discrete. You can't play many half CDs, so they're whole numbers. How much does this whale weigh? And that's continuous. Depending on what you measure in, it can go on. What is the temperature of this fire? Again, it's continuous because it won't be a whole number. How long does the bus take to Birchington? And it's continuous because do you measure in hours, minutes, seconds, milliseconds, etc. What is the breed of this dog? Now think about this. What is the breed? Is it discrete or continuous? Hopefully you got neither, because it's qualitative, because you can't measure a breed of a dog. So that's red, amber or green.